Welcome everyone. Thank you for joining us this afternoon for IAPD's monthly webinar presentation, PVC 101 Secrets Unveiled, sponsored by TMI LLC. I'm Liz Novak, IAPD's Director of Marketing and Communications. Before I introduce our speaker, I'd like to cover a couple of housekeeping items. First, questions will be answered at the end of the presentation, although you may submit questions during the presentation using the Questions tab on your toolbar. Second, you will receive a survey 1 hour after the webinar ends. Once you complete the survey, there will be a link to today's presentation slides. A recording of the webinar will also be available on IAPD's YouTube channel and on IAPD's website. Now a little bit about our speaker. Bill Haybeck began his career in 1987 in the Consumer Relations Department of the Goodyear Tire and Rubber Company. He then worked for 15 years as a product manager and eventually a business manager, running the Specialty Films Division of RJF International Corporation before becoming the Vice President of Sales and Marketing for both HPG International and Primary Packaging. Currently, Bill is the General Manager for TMI LLC's Manufacturing Division. We're pleased to have him as our presenter today, and I would now like to turn the presentation over to Bill Haybeck.
Good afternoon, everybody. We're so glad you could join us, or I guess morning for some of you. We're so glad you could join us for the PVC 101 Secrets Unveiled webinar. So I guess the first question I should answer is why the title, PVC 101 Secrets Unveiled? The first answer, I guess, is technical difficulty. Yes, the first answer is PVC 101 in the phrase represents digging into the basics of PVC or polyvinyl chloride, the polymer itself. Secrets Unveiled represents presenting the method in which PVC sheet is manufactured, as well as the truths related to phthalate plasticizers, which I know is a big concern and of interest to a lot of people, eco-friendly advancements in the marketplace and in the compound itself, and other little known facts. So having said that, let's jump into the webinar. So just as a brief overview, number one, we're going to talk about why PVC. Number two, we'll talk about polyvinyl chloride, the basics of the raw materials and compounding. We'll also talk about what material goes into PVC, the basic raw materials that make it up and how they help the PVC perform. We'll talk about PVC versus other polymers or other plastics. And we'll talk about the environmental or toxicity of PVC or the lack thereof. Number three, we'll talk about sheet extrusion made practical and simple. And four, we'll talk about some market applications. So why use PVC in manufacturing products? Four key reasons that we see. First of all, inherent flame resistance. PVC is naturally flame resistant. The thicker the material, the more resistant it is to flame and fire. Faster part approval. So if we take a sheet of PVC and we make parts out of it for, let's say, the automobile industry, the material meets agency flame ratings, which reduce part testing and turnaround time for getting the products out into the marketplace. Chemical resistance. PVC resists discoloration or stress cracking from cleaners, foods, oils, detergents, insecticides, and many chemicals. And there's a lot of information available online or through some of the references we'll show you later in the presentation as to what chemicals specifically it is resistant to. So UV resistance for an enhanced image of your finished products, in their final application, parts look newer longer because they resist discoloration due to UV exposure. PVC is naturally UV resistant. However, if there is going to be long-term outdoor exposure, then a UV inhibitor has to be used in the product to make it more UV resistant for a longer time. And specifically, if the part is used in New Mexico versus being used in Minnesota, you have two very different applications that it has to be prepared for with the UV inhibitor. Cost performance, reduced manufacturing costs in rigid PVC. Rigid PVC can replace higher cost engineered materials like ABS, polycarbonate, or ABS and polycarbonate. Flexible PVC can replace higher cost thermoplastic elastomers and rubber. Flexible PVC is also the most versatile and cost-effective plastic on the market, and improved manufacturing efficiency in the process, again, of making parts that your customers may be making, automobile industry, for a lot of other applications. Lower scrap rates, and PVC is 100% recyclable. So we've listed some of the many, many markets that are available. There are so many applications that we've just listed some of them, specifically maybe more suited to sheet extrusion and calendaring, which we'll get into a little bit more of an explanation later. But strip doors, such as walk-in, used for walk-in freezers or for freight doors, 8-inch, 12-inch, 16-inch strip, I'm sure you've seen that in its application. Clean rooms for medical device manufacturing, or for many different applications. Usually it's related to the medical industry. Computer and electrical equipment enclosures, data center enclosures, where you have to have no static electricity, so you use an anti-stat type product. Sound block or sound attenuation, huge market, where you might need to something like a theater application where you don't want any sound getting outside of the theater, so you build into the walls a sound block product. I mentioned automotive. There's so many applications in the automotive industry. The shades that go in the back of SUVs, the heel and toe pads that go underneath the matting in the front driver's side of the car. Tank linings, again, a broad industry. Tank lining is used for potable water tanks. We'll talk again about NSF 61, but for potable water, for grease tanks, that might be used at a restaurant, for instance, to store their grease out back. For fuel, for oil, spent oil at service stations, again, so many applications. Then there's geomembranes. The geomembrane market is huge. Pit and pond liners, even the little koi pads that people now find so popular, they're putting them in their, in the front yards. Those have some type of a PVC geomembrane in them. So again, many other markets. Some of the other markets, laminated products. I'm sure you're familiar with banners, tents, awnings, thinner gauge film that usually comes out of a calendaring operation and then is laminated into a finished product. Wall covering, commercial wall covering industry, and wall boards for prefab homes. Swimming pool liners, which are printed and either in above surface or below ground swimming pools. Tapes and labels, humongous market. The label market with Avery Dennison's and the 3Ms is a huge market for PVC. And as I mentioned earlier, advertising. And advertising can encompass both flexible products and rigid products. The rigid signs you see at POP locations or out in the yards of buildings or businesses. And again, many others. So let's talk about PVC, the basic product. A lot of misunderstanding and lack of knowledge, maybe is a better way to put it, out in the marketplace about what PVC resin is. I'm not a chemist. I'm not going to get too deeply into exactly, how it's, the basics of how it's made, but I do want to dispel some rumors and at least give a little bit of information on it. One of my favorites of the misuse of it is if you go into a DIY store like Home Depot or any DIY store in the country and go to their outdoor furniture area. The outdoor furniture area, if you walk up and you look at those plastic chairs sitting there, the cheap ones, $10, $20, whatever they may be, ask the clerk what it's made out of, and they'll tell you, it's made out of resin. What kind of resin? It's made out of resin. Well, the fact of the matter is it's made out of PVC resin. So anyways, PVC resin is the building block of polyvinyl chloride, or the building block of polyvinyl chloride sheet. It is a product of salt and oil or natural gas. Generally, in this country, natural gas is used to make polyvinyl chloride resin, but it's a combination of the two. Other polymers, as we'll look at later, do not use salt as one of the building blocks. That's the difference. So there's two primary manufacturing methods for PVC resin. There's a suspension method, which is basically made using a water and oil slurry. And then there's a dispersion method, which is primarily used for making adhesives and coatings of various kinds. When you hear of a PVC coating, it's made using the dispersion method. PVC resin accounts for approximately 50% of the content for a flexible sheet. Plasticizer accounts for 30 to 40% of the flexible sheet, so you see those two raw materials are by far the biggest, make up the biggest part of the product. And we'll talk a little bit here in a little bit about pricing and in the market pricing and how it's driven. But those two, if the market pricing affects either of those two, you can see how much of a difference that'll make on the cost of PVC sheet. Plasticizers are the additive that give flexibility and pliability to the flexible sheeting. Types include phthalates, which I'm sure all of you have heard of as allegedly a bad actor. Adipates. Adipates are generally used for low temperature applications. In other words, so if you have a freezer application or you have a cold winter or weather application, you're going to use adipates. And then there are phosphates. Phosphates are used as an FR or flame retardant additive in clear sheet. It helps maintain the clarity of the sheet. So let's talk about the remaining 10 to 20%. These come in varying quantities depending on what you want the PVC flexible sheet to do. Fillers. You want to use as much filler as possible because it's a very low-cost additive. It's basically calcium carbonate or clay. The stabilizers are used to stabilize the sheet during the processes, which we'll talk about here again in a little bit, either the initial compounding process or the calendaring or sheet extrusion process. They help keep the material clear. They help to keep the material from burning up. Some common stabilizers are barium zinc and calcium zinc. Next one is process aids. Process aids basically help in the processing of the material through the equipment. Too much and you have an exudation on the material. Too little, the material doesn't process very well. Fungicides, there's two kinds of fungicides basically, vinazine and zinc borates. Vinazine is very commonly used in wood to keep the bugs out of the wood. I mean literally bugs out of the wood. And fungicides, again, depending on the application, you have an outdoor warm weather application, you want to include more fungicides. Next one is flame retardants. Again, depending on the application, we'll talk a little bit about that here in a few minutes. more or less flame retardants. Again, PVC is naturally flame retardant, and the thicker and heavier it is, the more flame retardant it is. But the thinner you go, 3 mil material to maybe 40 to 50 mil thick material, or 51/1000ths of an inch, you're going to have to add flame retardants to that if you have to meet California State Fire Marshal or NFPA or one of those applications. So UV inhibitors, as I mentioned earlier, UV inhibitors keep the material from being in an outdoor application depending on where the material is placed. And again, anti-stats for those applications where you might be covering computers or other types of sensitive electronic equipment. You will need to add an anti-stat. I mentioned pricing in the PVC sheeting market. It's driven by two primary items, oil and or natural gas pricing. Even though most of the PVC sheet in this country is made, or the PVC resin in this country is made using natural gas, oil still is one of the big drivers. If you watch the pricing of oil, you can see what is going to happen to the cost of PVC. The PVC manufacturers still tend to follow the oil prices. As oil prices increase, prices for other polymers based on 90 to 100% hydrocarbon, and we're talking about polypropylene, polyethylene, some of the other polymers, they increase at a higher rate than PVC because PVC is 43% hydrocarbon based. So a lot lower usage of oil and or natural gas in the manufacture of PVC resin. The second one is seasonality factors. Seasonality refers to the beginning generally of the construction industry, and sometime in March, April timeframe when the construction industry starts to take off, you'll see the price of PVC resin, which affects PVC pricing, start to increase. Generally, at the end of the season, the building season, you'll see the pricing start to back off. There are other factors. These are the two primary typical ones. The hurricane down in the Gulf of Mexico, I believe back in 2005, made a huge difference in the pricing. It knocked out a couple of crackers, so they had to shut those down, and there was a raw material shortage for the basic building blocks of PVC. That type of thing will affect it. There were issues with some raw material supplies out of China a number of years ago, which dramatically affected it. We recently had a shortage in the anti-stat raw materials, which also affected it. Generally, these are the two biggest factors that will affect it. Very basic diagram of making polymers. Again, without getting too deeply into it, we laid out the basics of the differences between most polymers and making PVC. You can see where the hydrocarbons in the salt water enter into it together to make the PVC. They add the intermediate chemicals, put in all the other additives, such as we discussed earlier, the fungicides, the FR components, some of the other products that go into it, as well as the PVC resin, and you have your PVC compound. The main difference above, that it's 90 to 100% hydrocarbons, depending on what additive into it. There's a little graph that shows us the global demand. We looked at putting in a whole lot more information, but we didn't want to make it too wordy, so we narrowed it down to basically what we think are the important key elements. 2010 figures, the world polymer, every polymer used in the world demand was 419 billion pounds, staggering number. The PVC resin demand was 75 billion pounds, 18% of total global demand. So it's the second largest polymer used in the world, but there is a little bit of a side note to that. Polyethylene, if you just define polyethylene as PE, it is by far the biggest user in the world. You'll notice on the graph when you start talking about low-density polyethylene, linear low-density polyethylene, high-density polyethylene, they make up a pretty sizable part of the pie. And you have polypropylene, polystyrene, ABS, PET, and polycarbonates. make up the rest. USA and Canada, PVC demand in 2010 was 9.5 billion pounds. China, which everybody knows is growing dramatically, is expected to use or demand up to 44% of total global demand by 2020. They're going that direction. The United States is going the other direction. And understand, and we'll talk again a little bit more about this here shortly, but two of the biggest drivers in the PVC world are PVC pipe and PVC windows. Those two together account for a total of 58%, the total demand for PVC. Big drivers. So just a simple chart to introduce you to the variety of ways that you can process plastic. Sheet extrusion, which is primarily what we do here at TMI. Injection molding. Injection molding basically is injecting PVC into a mold. Automobile parts, body panels, that's the type of product that they get out of that process. Profile extrusion. Profile extrusion makes a rigid product, magnets for refrigerator doors, window frames. Those are examples of profile extrusion. Calendared vinyl film, much larger process, 9-foot diameter rolls. The machine itself is probably 60 feet long. Very, very complicated piece of equipment. Calendaring started back in the days of when the tire industry first started. They invented the calendaring lines to make the sheet rubber for the tire industry. Evolved into the PVC and other polymers being developed. And basically it makes a sheet that then is taken and converted into some type of a product for any number of end-use applications. You can calendar film down to 3 mil, 2.5 mil, or 2.5 thousandths thick, generally up to about 30 mil, somewhere in that neighborhood, although there are some calendars that will make heavier material. And blow molding is the last one. Basically, blow molding forms hollow plastic parts. It combines melted PVC and air to form these products. Spray bottles, as you'll note on the right-hand side. Water bottles, other drink containers, use your imagination. A lot of applications for it. Talk about some of the eco-friendly advancements. There's some pretty exciting ones. The first one, I would say, is one that is going to be something that is widespread. Many of the manufacturers of plasticizers have come out with a bio-based plasticizer. It's plant-based. What it means is a smaller carbon footprint, and of course it's a renewable resource. And all testing to date has shown pretty much that it acts and reacts just as a phthalate-based plasticizer system or adipate or any of the other types of plasticizers. So stay tuned. I'm sure we're going to hear quite a bit more about that one. And of course, lead additives phasing out in North America and Europe, just about there. And lead should be removed from these products. Not something that we want to put in a landfill, basically, is what it comes down to. Eco-friendly, there's less volatile organic compounds in PVC than in polyethylene, or generated, I should say, in PVC than in PE or PP or ABS. Vinyl chloride and chlorine gases not released if PVC degrades. Another misnomer out in the marketplace that if you put it into a landfill, you're going to get the emission of chlorine gases. Not true. PVC can be safely recycled, landfilled, and incinerated. PVC is processed at lower temperatures than competing polymers, i.e. it requires a lot less energy. Safe non-toxic polymer, PVC has been safely used for over 50 years. Vinyl chloride monomer, VCMs, are the basic building block of PVC resin. And I would encourage you to go online and look at the videos in Wikipedia or some of the other online sites that We'll show you exactly the process for making VCMs. It's a fascinating operation, but the exposure is well below levels that pose any type of a threat. FDA, Food and Drug Administration, has approved it for food packaging. The FDA and the United States Pharmacopeal have approved it for medical use. CPSC, which is the Consumer Product Safety Commission, a federal agency, allows vinyl use in children's toys. And we'll talk a little bit more about the phthalates and some of the other, again, misinformation that's out in the field a little bit later. The NSF International has approved it for potable water piping. NSF 61 specifically refers to that. Underwriters Laboratory, the CSA, a Canadian FR Codes approval group, California State Fire Marshal, National Fire Protection Agency have all approved PVC for fire safety. And finally, PVC has not been legislatively banned by any country or state or province. So let's talk about phthalates in children's toys. The Consumer Product Safety Improvement Act, phthalates provision for toys. We've provided, and we'll just take a quick glimpse at it at the end of the webinar, we've provided a full breakdown, a two-page breakdown. It's very wordy, very complicated, but we provided that at the end of the webinar. It will be included in the webinar notes, so that if you want to refer to some of the legislative action that has happened with phthalate plasticizers, you'll have it at your fingertips. So the CPSIA restrictions apply to specified phthalates. Permanent restrictions, there are permanent restrictions on certain phthalates on use in children's toys and articles with concentrations of greater than 0.1%. And those three are listed. Temporary restrictions, and again, we'll go look at some of the notes from the appendix. The temporary restrictions were placed on DINP, DIDP, and DNOP. DINP and DIDP are by far the two phthalate plasticizers used in the production of flexible PVC sheeting, by far. But these temporary restrictions aren't what they appear to be. Again, we'll talk about them shortly. So let's go through the basics of the process now. The basics of compounding. The raw materials that we discussed earlier are taken and mixed together in either an intensive or a ribbon mixer. Basically, it's a blender. Those mixed raw materials are then transferred to a compounding line. And you'll see a picture of what is called a kneader on the left-hand side. The compounding line can be either single screw, twin screw, a continuous, or a kneader. The materials are then pelletized. And if you've been in a processing plant like a sheet extrusion or calendaring or some of the others, you'll see in the pellets, they are just exactly what they sound like, little pellets. And in the background on the screen, you look hard, you'll be able to see pretty much what they look like. But they're air cut, underwater, or strand cut. The pellets are then packaged and shipped to the processors. Here's a picture of a typical sheet extrusion process. You can see 3 sheet extruders in this operation. And we're going to walk through the process. You're looking at the wind-up end where the rolls are wound up on cores. The far end is the beginning of the process. So let's walk through it. Here's a diagram of how it works, basically. Material is fed into a hopper, the compound. Material then is put into the single screw or twin screw extruder. It is then fed into a thin lip die, and out of that die comes a very molten, very liquid product that then is fed through typically three chrome rollers. You can see the path of the material as it goes through. The material then goes through a cooling water bath and out into a slitter where it is slit down to various widths. That's the point where you get your 4-inch wide, your 6-inch wide, your 8-inch wide, whatever the width might be. The excess material is then removed and driven back through the process. With the 100% recycle part, it's driven back through the process and reused at about a 25%, maybe a little higher rate. Material then goes into a winder where it's wound up on a core or on various cores, depending on the product you're manufacturing. So let's walk through it real quickly. Compounded raw materials, as we mentioned, are moved to the manufacturing area, typically in boxes, gaylords, or via a silo. Silo is the most efficient way to do it. You fill the silo up and then vacuum basically the materials out of the silo into the dryers or the hoppers. Compound then is taken from that point into a system of hoppers and dryers, and that's the image on your left. You can see the vacuum hose in the gaylord removing the compound from the gaylord. Compound then proceeds through to a single or twin screw extruder. That's the image on the right and the highlighted image below. This material is then conveyed through the screw and into a sheet die. The compound is remelted and mixed by both shear heat and pressure through this process. So, as we mentioned earlier, it goes through the extruder through a process where it is melted in the screw and out through the die. On your left-hand side, you can see an example of a die. This is what is known as a coat hanger die. There are two other types, pipe die and plate dies. After exiting the die, the PVC is then forced through a series of chrome rolls. Thickness of the material through these two processes is determined at this point in the process. Typically in a sheet extrusion operation, which is what you're looking at material anywhere from 30 thousandths thick up to as much as a half an inch thick. Quite a broad range. Those three rolls, typically there's three types of rolls that are used. A high polished roll, a frosted roll, or this is where the embossing is done on the material. If you have a light stipple or a leather grain emboss, you would remove the top roll in the stack and put that embossing roll into that point, and that's what gives you the embossing on your material, or the grain as some know it. Form sheet then goes through a cooling process. It can include a water bath, which is the image on the top, or chilled rolls, which are not pictured. Chilled rolls are typically used in a calendaring operation, but they can be used in a sheet extrusion operation also. Light boxes, this is where a lot of the QC is done from an operator standpoint, installed for visual quality and control at this point. You'll see that image on the bottom there where the operator is checking the appearance of the material. This is where you can detect any visual quality issues and go make adjustments on the equipment. Knives or slitting equipment, pictured on the left, such as crush cutters, are set to slit the wide sheet into specific roll widths. Being used on the left-hand side are knives. Excess PVC is then recycled, reground, and put back into the process. And if you look closely at the picture, and we actually have a video to show you that'll illustrate this a little bit better. But the material in the middle and on the sides that's being pulled taut is being fed into a grinder and then back into the front of the process to be 100% reused. And finally, the winder. This is where the material is wound up on cores, as pictured on the left-hand side. And typical types of wind-ups found in the plastics processing industry are surface winders. Much more broadly used are turret winders, where you basically have a continuous process as you cut off one roll and start on another roll. Okay, short video. You can see the material is going through the three-roll stack at this point. Coming out still very warm, heading to the water bath. Cools the material and sets it, basically, through a series of rollers, which is where the inspection is done and further cooling takes place. And the final, the cooled PVC is split down on the final roll or roll widths at the knives, where we mentioned the knives are the crush cutters. This is where the recycled material is fed back through. Finally, the finished rolls are wound onto cores. So let's talk about some market applications. Some of the market applications you see pictured here, as we mentioned earlier, are the strip doors. What you're looking at are warehouse doors, especially handy in the winter months or to hold down dirt and dust. You put these strip doors up over these doors, the opening here, and it cuts that cold air or the dust and dirt off from the rest of the manufacturing or converting facility. These are used in so many applications across the world. Freezer doors, walk-in freezer doors at restaurants or grocery stores or storage facilities of some sort. We've seen them used in agricultural applications, in barns even, to hold down the weather between the animals and the outdoors. Such a huge variety of applications. A great seller. Data centers, as we mentioned earlier, used as overall enclosures, but also to separate the computer equipment or the servers. Anti-stat is a very widely used product in that industry. Also flame retardant, of course. On the left-hand side, you see tank linings. Again, a huge variety of tank lining applications in the marketplace for holding any number of types of products, chemicals, grease, potable water. On the right-hand side, you'll see enclosures. If you notice in the background, there's a clear sheet enclosure being used on this application. And in the background, you might notice coated or laminated fabrics on the tops of those tents. That, of course, uses PVC sheet for laminated products and a dispersion coating on coated fabrics. So, quick summary of what we talked about today. The compounding raw materials are mixed and extruded as pellets. The extruding process, pellets go through a series of hoppers and dryers, then through a single or twin screw extruder. The hot material winds through a 3-roll calendar stack, and it's embossed at this point. PVC sheet is cooled and wound onto cores. Some of the markets then that we've talked about commercially are listed below. And of course, there's so many other markets that it's obviously difficult to list those here. So here's a slide that can provide you with additional information. I want to skip by this real quick. Just take a quick look at the appendix. You notice the second bullet point. Temporary restrictions were placed in 2009 on the sale of children's toys that can be placed in a child's mouth. Toys that can be put in the mouth are defined to include toys or parts smaller than 5 centimeters in one dimension. Toys that cannot be put in the mouth but can be licked are not included. So there are some temporary restrictions that are on the materials, but they're very small. The play mat in a child's play pen, for instance, is made out of PVC. That would not be included in this type of a restriction. Then the second page has a lot of interesting information on DINP and or phthalates, I guess, as a whole. In 2001, a review was done of the safety of DINP. It concluded that for the majority of children, the exposure to DINP from containing toys would be expected to pose a minimal to non-existent risk of injury. So that was a previous ruling. CPSC has never expressed immediate concerns about phthalates used in toys and child care articles. Therefore, consumers should not be alarmed or concerned that some children's products may still contain phthalates. So again, those will be in your meeting notes as ready notes when you have the opportunity to talk about those issues. Again, here's some resources you might want to list for further information. A lot of good information online available through these. So we're going to open it up for questions.
Yes, Bill, thank you for a great presentation. And everybody on the call right now, please feel free to send in your questions using the toolbar on the right, and we will get those answered for you. Just so you know, in about an hour, you will receive a survey about this webinar. Complete the survey, and then you'll get a link to the slides. So you will be getting the slide materials. I know the last two slides in the presentation are kind of information dense, so you know, you'll want to be able to go back and look at those some other time. And we do have our first question. Let's see. Okay, Bill. Can PVC extruded sheets be used in conjunction with polycarbonate extruded sheets?
That's a good question. I do not believe so. I know PVC sheet has been used in conjunction with polyethylene and thermoplastic urethane. I do not believe it can be used in conjunction with polycarbonates. I guess my question back would be, what would be the application and what are you trying to accomplish? Thermoplastic urethanes are very good scratch-resistant materials and can be used in conjunction.
Okay. So for our person who asked that question, if you can, you know, let us know what your application is, we can get you an answer. Okay, the next question we have is, besides barriers, what other applications would you recommend for converting to your PVC product?
I'm sorry, can you repeat that?
Besides the barriers, like the strip door things, what other applications would you recommend for converting to your PVC product?
There's quite a variety. I'd refer to the website listed at the top for all the applications, but there are enclosures, there are walls, such as gymnasium. When you want to separate two sections of a gymnasium, you pull that wall across. There are enclosures for factories if you need to hold down the dust and dirt from one part of a factory to the next. Weld screens for putting an enclosure around welders. You know, when you need to cut down on the amount of light that's coming from the welder itself, you use a weld screen material which is colored. Mm-hmm. Tank lining we mentioned before. Yeah, quite a few other applications.
Okay, great. Okay.
But again, the website at the top lists a lot of different applications if you're interested.
Super, what a great resource there. Okay. Another question, is clear PVC as UV resistant to color shift as gray PVC?
Without including a UV inhibitor in it, no. When you put a pigment into a product, it makes it that much more UV resistant. So a gray naturally without a UV inhibitor in it would be much more resistant to UV rays. If you put a UV inhibitor in a clear material, it can be every bit as resistant as the gray.
Okay, great. Okay, we're getting some good questions here. The next one is, Bill, you said that the PVC sheet thickness varies from approximately 0.03 inches to a half an inch. What are the reasons for these limits?
It's equipment related. You know, you have the die where you're extruding material, and that kind of a range. And this again is on sheet extrusion. Calendaring can go quite a bit lower, but sheet extrusion, you have a die that you're controlling that gauge and that thickness. So to go any heavier would be beyond the die's capability, basically. To go below it, you have trouble extruding it out of that coat hanger die that we showed you earlier.
Okay. All righty. Next question is, what is the difference between extruded and calendared vinyl in the graphics market, or do the terms mean the same thing? In
the graphics market, Calendaring can do thinner gauge generally. Now there are some extruders that specifically are set up to do thinner gauge material. Calendaring can do, so if you have your 10-ounce material, for instance, or your 10 mil or 12 mil material, or your 18-ounce products that include calendared vinyl, that's much more suitable for the calendaring industry. For the heavier gauge products, especially where rigid is concerned, or 40 mil or 40 ounce, I should say, laminated or coated materials, that would be more for the applicable, of course, for the sheet extruder operation. Rigid PVC at 90 mil, for instance, is a typical signage product. That has to be a sheet extruded product for your printable signs and et cetera.
Okay. Alrighty. Have you faced challenges in regards to lead?
We actually are embarking on that. We've had a quality program in place here with all the specifics necessary to run a quality program. But we are embarking on lean. That's a great question. It's a great program. We've started the beginning process of studying the small Kaizen improvements. First of all, so the answer to the question is no. We haven't encountered any issues with it yet because we're just starting on the entire process.
Okay, great. I might not have enunciated well enough, though. They were asking about LEED, L-E-E-D.
Oh, I'm sorry. I thought you said lean manufacturing. So,
no,
yeah.
no, it's perfectly. No, it's probably me. But so,
Right.
what about?
I misunderstood you.
What about?
So you got an answer on lean manufacturing too, without even having to ask the question.
There you go.
But lead manufacturing. No, we are not. Most of those markets are in the building industry.
Okay.
We have had some inquiries on the strip door side, and with some of the coated fabrics we sell as a company, but we have not encountered any real issues meeting any of the requirements that they've asked for from the few standpoints that we've actually encountered it.
Okay, good to know. Good to know. Another question is, what is the injuries in quotes, sustained by children who are exposed to the PVC? I guess what are the reasons behind the legislation about the usage of it in children's products?
Well, there is one comment. There's one comment in this, and I jumped to this page. Mm-hmm. I'm not an expert on that, and I can't really comment on what those injuries might be. But if you read the third bullet point here, might be a risk to children who mouth DINP plasticized toys for 75 minutes a day or more, day after day for an extended period of time. However, mouthing experiments showed that children kept toys in their mouths for less than 2 minutes a day. So really, again, I'm not the expert on that, but that is one of the comments that happened to be included in the appendix.
Okay.
And I should say also to take a step back to the lead question, that strip doors can actually help you meet the requirements of lead.
Okay. Good to know. All right. Are you up for a few more questions? They keep coming in.
Sure, and I'm going to refer some of these to Jim Lutz, our manufacturing manager, who is in the room with me,
okay,
and to Norma Spence-Turner, who is our process engineer, quality person. So I'll try to answer them. If not, I'll defer to them.
Super. Okay. The next one is, how does PVC pricing generally compare to pricing of other polymers? For example, PP or PE?
Generally, PVC pricing is lower than the other ones as a finished product. As a finished product. I should say sheet products or calendared products from sheet extrusion. Generally, PVC is much more cost-effective. Again, it depends on the application and what are the raw materials that are built into the product. As far as the final application goes, generally less expensive.
Okay. All right. Next question, is lead still used as an additive in any PVC-related product, or is it completely banned in the United States?
That's a great question, and I'm not the expert on that answer. I know that most manufacturing processing facilities in the United States have removed lead from their operations, all forms of lead, all types of lead. There still are some leads used in the colorants, in the pigments that are used. They have not been completely banned from those, all leads. Some have not. But generally, manufacturing operations in the United States have removed lead from their operations. Our facility here, for instance, is totally lead-free.
Great. Okay. Alrighty. Another question is, why have so many companies either banned PVC products or put severe restrictions on PVC, including, for example, Walmart for consumer products in general, beyond just children's toys?
Well, as we mentioned, PVC has not been banned from any country or any municipality. I am not aware of the fact that Walmart banned PVC from their operation. I can tell you, you walk into a Walmart and 20 to 30% of the products they sell in a Walmart contain PVC. Mm. So what they have banned are lead-containing PVC, and it's been an issue with products imported from other countries. So that's why they got very visible and very vocal about banning lead-containing PVC. As far as I'm aware, they have not banned polyvinyl chloride as a whole. Polyvinyl chloride comprises a large, and I'm not going to guess at the number, but a large percentage of most car interiors. For instance, even a car that's a leather interior has PVC-backed seats, the steering wheel, the dashboard. So again, as far as I know, no entity has banned PVC.
Okay. All righty. And it looks like that covers all the questions that have come in. So thank you, everybody. Really appreciate it. Thank you, Bill. If you do have follow-up questions, please contact Bill, I guess at the 800 number that's showing on your screen right now. And before we go, I am excited to announce that, and you're hearing it here first, that Sam Richter, who was a very popular keynote speaker at the IAPD convention in Miami a couple weeks ago, will present a webinar on Thursday, November 14th at 9 a.m. Central or 10 a.m. Eastern, called No More, that's K-N-O-W, More Selling, Part 2. And a link to register for this webinar will be available once you have completed today's webinar survey. And I would also like to once again thank our presenter, Bill Haybeck, and TMI LLC for sponsoring today's webinar presentation.